Hello. Have you ever been asked this kind of question before? How many trailing zeros does 56 factorial have? Now, for clarification, the number 1000, as an example, this number here has 3 trailing zeros, right? 1, 2, 3. Or you can say terminating zeros, right? They're kind of like a tail of zeros here. And if we took the number 20,100 as an example, this number here has only 2 trailing zeros, 1, 2. And this zero here doesn't actually count as a trailing zero because it's not part of the tail of zeros, right? It's not like a terminating zero. It's not like the number ends in this zero. So since this isn't part of the tail of zeros, this one doesn't count as one. So that's 2 trailing zeros. Okay, so now that's out of the way, let's answer the question. If 56 factorial were to be evaluated, how many zeros would the number end in? Well, we're not going to actually evaluate it because this is a very large number. So we need to think of another way to solve this problem. Let's go ahead and try a few basic questions to help us get an idea. If I told you to evaluate 3 times 5 times 2, what would you do in this case? Well, you could of course do, okay, 3 times 5 is 15, so you just get 15 times 2, and 15 times 2 is 30, so your answer would be 30. Okay, that's correct. But what else could you do? You could also notice that you can do 5 times 2 first, and you get 3 times 10, right? And then when you multiply by 10, you just have to append this 0 to the 3. So your answer would just be 30. You get the same answer. Now, what was better about doing this method? Well, the better part about it was that you could just append the 0 to the 3. It made the work much more quicker. You didn't have to do any actual multiplication in that case, even though this is actually multiplication. But using the rule for when we multiply by 10, we could get the answer quickly. And we're going to go with another question to really help us get the idea if you still haven't gotten it. If I told you to evaluate 10 times 10 times 10 times 243, what would be your answer? Well, this time there are 3 10s here in the product, and we have a 243. So our answer will just be to append these 3 zeros onto 243. And so our answer would be 243,000. Okay, have you noticed the pattern? Whenever we multiply by 10, that appends an extra trailing zero, right? So for every time 10 is multiplied in the product, an extra trailing zero is added. So, in order to find the number of trailing zeros in 56 factorial, we just have to count the number of times 10 is multiplied in the product. Or in other words, we just have to count the number of factors of 10 in 56 factorial. So let's do that. Let's write out 56 factorial roughly. So 56 factorial, this is equal to 1 times 2 times 3 times 4 times 5 times all the way to, alright, the last two numbers, 55 times 56. This is what 56 factorial is equal to, the product of all the integers, positive integers, from 1 to 56. So, how can we get factors of 10 in this case? Well, notice that we have a factor of 10 right over here. We have a 2 and we have a 5. These two multiply to become a factor of 10. Okay. And we also know that in 56 factorial, we know that since 56 is obviously greater than 10, there will be a 10 multiplied somewhere in this factorial. So there will be directly a 10 multiplied, and that's another factor of 10. And we know that there's also going to be a 20 that is multiplied in here, 30, there's also going to be a 40, there's also going to be a 50. These all contain a factor of 10, so these are just more factors of 10 to consider. In fact, why don't we take a look at 4? If we take a look at 4, well, we know that there's a 4, and somewhere in 56 factorial, there's also going to be a 15. And we know that 4 times 15 is equal to 60, which in 60 there is another factor of 10. In fact, if you actually take 55 times 56, this will also give another factor of 10, because the product of 55 times 56 will give a number that has a factor of 10, or at least one factor of 10. And those are just maybe some of the cases that we've only considered so far. So we can see that counting the number of times 10 is multiplied, or rather the number of times the number of factors of 10 in 56 factorial, that can be kind of hard. So let's think of a way to break 10 down so that we can count it more manageably. Now, 10 is a semi-prime number. What does that mean? Well, that means that 10 is the product of two prime numbers. And surely, we know that 2 times 5 is equal to 10. So notice that 2 and 5 are both prime numbers. So in order to count the number of factors of 10, we just need to count the number of pairs of 2 and 5 that appear in 56 factorial. So in other words, for every pair of 2 and 5 that is multiplied in 56 factorial, that will be another trailing 0. Okay, so how do we count the number of pairs of 2 and 5? Well, again, we have already a pair here, 2 and 5. That's already a pair. And we also suggested that, remember, 4 over here is equal to 2 times 2, right? And we know that there's going to be a 15 down here somewhere. And 15 is equal to what? 5 times 3. And notice that this 5 and this 2, any of these 2s, can combine to make another factor of 2, which is a factor of 10. And we can see that we can think of more cases that we can find a pair of 2 and 5 in 56 factorial. Try to come up with some on your own. So we know that counting pairs is going to be still a little bit hard. So how can we reduce the work even further? I'm going to give an example to help us reduce this work further. Let's say that you had an empty box and that you had exercising weights to put into that box. And let's say that the weights that you have are 5-pound weights and 10-pound weights. Let's say that the 5-pound weights are smaller in volume than the 10-pound weights. Then, let me ask you, can I fit more 10-pound weights than I can fit 5-pound weights? Of course not, because the 10-pound weights have a greater volume than the 5-pound weights. You can always fit more 5-pound weights into that box than you can fit 10-pound weights. And likewise here, notice that 5 here is greater than 2. And that's obvious, but how does this help us? Well, since 5 is greater than 2, we know that you can fit more 2's into 56 factorial than you can fit 5's. In other words, there will be more factors of 2 in 56 factorial than there will be factors of 5 in 56 factorial. Or you can also say that 2 can divide into 56 factorial more times than 5 can divide into 56 factorial. Since 56 factorial is just the product of all the positive integers from 1 to 56. So, we know that however many factors of 5 there are in 56 factorial, there will always be enough factors of 2 to be able to make a factor of 10 by combining the 2 and 5, right? Because however many factors of 5, you can always find another factor of 2 to pair up with that 5. Because there are more factors of 2 than factors of 5. So we just need to count the number of factors of 5 in 56 factorial. Now this is much more easier. Why? Because 5 is a prime number. You can't break down 5 any further. Unlike with 10, which is a composite number, you can break that down, which made counting the number of factors of 10 not easy. But 5 over here is prime number, so you can't break it down further. Okay, so how do we count the number of factors of 5 in this factorial? Well, the only places you can find factors of 5 in 56 factorial are at numbers which are multiples of 5. So, the only multiples of 5 in 56 factorial, for example, would include 5, 10, 15, 20, and so on. So let's list out all the multiples of 5 in 56 factorial. There is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and 55. It doesn't go to 60 because it's only up to 56 factorial. Okay, so now that we know this, how can we count the number of factors of 5? Now, these are the only numbers that have at least one factor of 5. So, do we just go, okay, well, each number has one factor of 5, so we just count 1, 2, 3, 4, 5, 6, 7, 8. Do we just do that? No, we do not. Because we have to be careful of something. A number can have more than one factor of 5. Right? And the truth is here that there are numbers in here with more than one factors of 5. So if you just counted 1 for each number here, you would be undercounting. You wouldn't be counting quite enough. So we have to determine the numbers that have more than one factors of 5. Well, which numbers here have more than one factors of 5? Well, notice that 25 is 5 squared, so that's 2 factors of 5 there. And notice that 50 is 2 times 25, which is 2 times 5 squared. Again, 2 factors of 5. So, among all the numbers here, we know that 25 and 50 have more than one factors of 5. Namely, they have 2 factors of 5. All the other have only one factor of 5. And you can check if you want to. So, we're going to count them, except we're going to double count for 25 and 50, because they have 2 factors of 5. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So therefore, we know that there are 13 factors of 5 in 56 factorial. So since there are 13 factors of 5, we know that there will be enough factors of 2 to make a pair of 2 and 5. And since there are 13 factors of 5, there must be 13 pairs of 2 and 5 in 56 factorial. And if there are 13 pairs of 2 and 5, then that means that there are 13 factors of 10. And 13 factors of 10 is what? 13 trailing zeros. So therefore we know that 56 factorial has 13 trailing zeros. And that is our answer here. Our answer here is this factorial has 13 trailing zeros. And that will be our answer.